Hi everybody. First of all, I would like to thank to Arango DB to invite me here to speak on this event. So today, I don't know if we have time. I'm a slower-ish speaker, but we will see. If we have time, I would like to tell you about the Spline, the project itself. Basically, the idea behind the project. We will talk a little bit about lineage and problematic of capturing lineage. Then we will talk very briefly about how we leverage ArangoDB features in this project. Then, of course, I will show you a live demo. And in the end, I have a bonus slide, very rough POC of applying the LangChain framework to build some natural language interface to Spline. Well, okay, let's start. So just a very few words about the statistics and the usage of Spline. Spline is an open source project, so we do not trace. We have probably almost zero ability to know how many companies and how many users out there using Spline, experimenting with Spline, etc. But we do have some feedbacks. And we do have stargazers on the GitHub repos. So this is that very little source of information that we can use to actually make some sense of how Spline is being adopted around, basically, in the community. So we have almost 1.5 million pools of our Docker repos, which basically speaks for itself a little bit. And also among the stargazers, we have such companies as you can see here. Again, I cannot tell if they're using Spline or not, but those are just people who start our repos. And some companies, like for example, Riot Games, specifically gave us feedback and thank for the project, so they are successfully used it on their production. BMW did a really good, analysis about the ways how to capture lineage, and basically published a paper about lineage capturing and Spline specifically. So. Yeah, AWS published a blog post about Spline. You can Google and find it there. All right. So, what's the basically lineage and why it is important? First of all, I would like to ask if anybody is familiar with Spline and overall data lineage tracking here in the audience. Do you use Spline specifically?
No, I evaluated it, but we using database.
Okay. All right. So basically, data lineage started being a very important topic together with growth of the big data field, right? So the company started processing data, creating a lot of data processing pipelines that also incorporate complex logic in the basically in those pipelines, ETL processes, then doing some analysis on the data and creating some reports, etc., right? And the more data is being processed in the company, the more complicated pipeline gets. It's more and more difficult to keep trace on things, to see the complete picture, to capture errors, to basically just to keep an eye on things and just to verify if our pipelines is actually doing what they're supposed to do, right? This is one huge problematic. Sorry. Another problem is, as I already quickly mentioned, basically the troubleshooting. So from the perspective of data engineers, if something goes wrong, without lineage, without understanding how your pipelines actually built and what is taken from there and what impacts what, it's very difficult to troubleshoot an error, to understand where this error comes from, if it's somewhere upstream, and on the other hand, what other jobs and what other reports might be impacted by this error downstream, right? And the third thing is governance and compliance risks, right? So in the recent years, we have some regulations like GDPR, BCBS, that specifically basically demand and impose some restrictions on the way how you process your data in the organization, right? So it's important to prove, let's say, to the regulator that some data that you sell does not actually contain some sensitive information, or otherwise it comes from reputable sources, not just from some some unknown sources, the stuff like that. So basically, the lineage. I like this definition, right? So this is a very abstract, but it basically says it all in one sentence, right? So the lineage, it's life cycle of the data that includes three main keystones, right? The data origins, like where the data is taken from and where it is written to, right? It also describes the way how the data is transformed along the way, and also it captures the exact moment in time when a certain transformation happens. This is the definition of the lineage that we use in Spline. So we basically we look at the lineage as a multi-dimensional graph of events. We do not look at lineage only as a, let's say, something static, some static picture, as some of the proprietary systems do. Like, for example, they some systems that I've seen that they may scan, for example, the database, just find some relations between the table, and say that, okay, this is the lineage, right? So one table is created using this query, so it depends on this, and that, etc., right? But that static picture misses one important thing, and this thing is time, right? So without actually tracing the order of events in your system, what query was executed first and what was the last, it's difficult then to see the lineage and of the particular kind of snapshot of the data, right? So you may see the dependencies between the sources and between the jobs, but you will not see the actual how to say the actual like flow of your data from the very source to the particular report that you are analyzing. So Spline tries to capture lineage in this kind of extended vision, extended form. Right. So one of the objectives of Spline is not only to capture the lineage from a specific framework or specific library, but rather so basically we understand that capturing lineage is a complex problem, especially in the real-time enterprise organization. When in one organization there might be various of different data processing systems and frameworks applied at the same time, right? So some of them are proprietary, some of them open source, some of them custom built, etc. And everything exists in the same company at the same time. So it's very difficult to expect that one company would be using, let's say, Apache Spark everywhere for everything, right? If it were possible, that probably such a project as Spline wouldn't be needed, because nowadays pretty much every vendor who provides a data processing framework or system also provides a capability to capture lineage at some extent, right? But unfortunately, it's not a realistic scenario. In reality, there are too many different systems, and from the business perspective, it's very important to see the end-to-end lineage from the very source to the very end. That's why in Spline we basically decided to abstract from the particular technology and create a system that would be maybe not too powerful right out of the box, but what is more important is that it would allow for extension. It would allow to adapt this system to a specific set of systems, data processing frameworks that are used in a particular organization. So that if some organization decides to adapt Spline to their own ecosystem, it's possible to do. And again, very quickly, for whom such lineage capturing system could be useful. There are three main groups of potential users that I can see. Those are data engineers and platform teams, basically the people who create data pipeline. They might use Spline to verify the structure of their pipeline if the stuff they build actually doing what it's supposed to do, right? Then the data scientists and analysts, again, might use lineage to basically, again, to verify the logic, relationship in the data, etc., etc. And the governance and compliance officers to prove or disprove some dependencies in the pipeline. All right, so any questions so far? Yeah, good. All right, so talking about the system design, it's important to mention that Spline is not a single box solution. It's rather a set of loosely coupled components combined with one clearly defined API that is used basically for communication between those components. So the central component is the Spline server, which works as a hub. That's a servers that exposes two set of independent API. One API is called Producer API. It is designed to be used by the agent components that are completely independent pieces of software. It's totally decoupled from the rest of the system. Each agent is basically a program that sits inside or very close to some specific data processing framework. I don't know, Apache Spark, Flink, whatever, right? Some custom scripts, etc. And the only job for those agents is to capture the event, capture the transformations that are happening in that system, and send this metadata to the Spline server in a Spline well-defined format. So that's it, right? So agents are just those small, simple things that keep an eye on the pieces of the pipelines that are spread across the entire organization, and simply send the metadata information just about those particular events, what has happened when, and that's it.
When you talk about these agents, these are like Java agents or instrumentation agents which are intercepting the calls and sending the
Technically, it could be anything, right? We call it agent because it's agent from the perspective of Spline architecture, right? But how it is implemented, it depends on that particular technology, right? If it's, let's say, if you have a custom data processing system that is written in Java, and there is no other sensible way how to get the execution plan and how to get the information from the basically from the system about what it's doing, except that creating a Java agent. Okay, you can create a Java agent, right? But Java agent, that's a totally different thing. That's a pretty much complicated thing. Usually, systems provide some sort of the internal API that you can use to basically to pull the lineage meta information from that system, convert it into our format, which is basically just a JSON in some specific structure, and send it to Spline server, right? So technically, it's not an agent like in terms of Java agent. It might be a very simple piece of program, but from the Spline perspective, it's called agent.
So in that case,
Yeah.
how it is different from Calibra harvest?
Yeah.
Calibra harvest is very similar to that, right? It's harvesting the information from various sources, you dump it to Calibra, and then you build that horrible UI to show it. It's very much similar to that, right?
Yeah, basically. So yeah, you might call it harvesters.
One more question.
Yep.
In terms of the metadata that you extract, depending on the system, you may not have all of the various pieces. So what is the minimum requirement in terms of the data you're capturing for this to work?
Oh, okay, good question. So basically, on this slide, you can see the conceptual data model for the lineage information, lineage metadata. That is the core, basically core model for Spline. So it's designed in a way that it has some mandatory data. That's what is your question, right? Some mandatory data that you need to provide, and a lot of additional, more specific layers that if your system or your agent is able to provide that deep level of information, that's cool. You can send this information to Spline, and Spline will be able to then provide better insight into the lineage to the users who views the combined lineage information, right? But it's not necessarily required. So if you are dealing with some custom or I don't know, some proprietary system that is very closed and you cannot use any sensible API to get useful information from what that system is doing, at least you need to provide basically two things to Spline in order to at least capture the lineage, end-to-end lineage, like on a high-level basis without any details, right? And those things are data source, right? And well, execution plan. It might be it might contain no details, but this is the thing, right? You need to provide some execution plan, some information about the data sources, where the data is read from and where it is written to. And then you need to specify the moment in time when this transformation or this write happened, right? So basically, these three entities are the basis. They are mandatory in order to make this lineage information usable at all, right? And all the other layers, they just add more details to the picture. So if your agent can capture the operations, can capture the execution plans, perfect. You will be able to analyze things more in details. You will be able to see the logic inside your jobs, etc. If your agent is capable to capture the attributes, the schema of the files that are read or written, perfect. You will be able to build attribute level lineage, for example, etc. Right? And for some the most sophisticated systems like Apache Spark, you can even capture the expression so that you may be able to see how one attribute is created, is computed from other attributes, etc. Right? Sorry, I don't hear.
These are all technical metadata you are capturing. What about the business? Did you also capture the business metadata also?
No, we're talking about technical lineage, basically. Okay. Yeah.
What do you mean by business?
So understanding of the data is more important than producing the data. So if somebody is saying that my KPI is 20% increase in the sales margin, you want to understand how this thing map back to the technology, and you can trust the data. So that was the question.
Yeah, that's a very good point. Spline is about to capture technical lineage. It's all about capturing lineage automatically without any kind of involvement of human, right? So we cannot capture business lineage because, well, that's the I think that's the boundary between the previous between this presentation and previous presentation, right? So if we maybe start talking about what's called the knowledge graphs, right? So this is what could create a business lineage, but here we're talking about purely technical lineage, basically analyzing and capturing the data transformations, and that's it.
With the operation box there, would that indicate transformation, how you're transforming data?
Yeah, operation might be like projection, joins, unions, filtering, sorting, whatever.
So in a way, that can capture business logic in terms of what your pipelines are doing.
Yes, but it's not.
But not the data, but how the data is being transformed.
Exactly. Yeah. Another very important point is that Spline does not do anything with the data. It does not capture data, and it is not interested in data itself. So because of the Spline architecture, the Spline server sits somewhere in the corner and simply waits until agent sends some metadata, some lineage metadata information to the server. So the Spline server does not need to apply for any permissions to access some database, to grab some lineage from there. No, this is the business of the agent to actually to separate the value, the data itself, which might be sensitive, which might be restricted in some sort of things, right? And from the metadata, and only send the metadata to the lineage, and that's it. To the, sorry, not to the lineage, to Spline. Okay, so the data model itself, basically, it forms a graph. Right? So the lineage, if you think about it, it's inherently a graph structure. Right? So we create, like Spline creates a multi-dimensional graph of things, which is ever growing. Right? So in the database, it might look like this. This is a made-up example, right? So you have, let's say, a data source A, which is read by job 1, and output to the file B, which is in its turn consumed by the job 2, together with the third file C. For example, there might be a join inside it, right? And the fourth file produced as a result, right? So this is a static representation of some data pipeline, right? But looking at this graph, you cannot really say what is a true lineage. Or for example, if I take a particular instance of file D, this exact file which lies currently on the HDFS, for example, right? What is the lineage of this file? Because there might be other jobs that write to the same file, and I have no idea when I take this particular file at this particular time. I have no idea the result of which job this file is, right? So that's why the time information is crucial for Spline, because we strive to provide a true dynamic lineage. So when we know exactly at which job is executed at what time, we then can add this chronology dimension, time dimension to the graph, and we may traverse it in a way to basically to specifically show what exact job was used to produce this file, and then if that job consumed other files, what exactly data was consumed at that time, and what jobs produced that data in its turn, etc., etc., etc. Right? So we may, knowing the time information and the static information about those data transformation, we can provide a true lineage for the certain snapshot of the data that sits in some particular file in some particular time. Then, if you want to drill down, if your agent is able to to capture not only the data sources and script names, but also some operations, you can enrich the database with the information about what actually happens inside the job 1 or inside job 2, etc. There's a join, there's a read operation, write operations, etc., etc. Right?
In an operational world, if, for example, we expect a report and we're missing some data, we could look at this graph and see, hey, there's a filter that was added recently that removed the field that we're actually looking for, so we can troubleshoot quite quickly.
Exactly.
Upstream and downstream.
Yeah. Right. So again, another level of details is a schema and attribute, and even expression. If you know expressions, that you can do a very in-depth analysis on what is happening in your jobs. Basically, you can almost debug those jobs, right? All right. So just very few words about ArangoDB. So why we picked ArangoDB and what is those killer features from our perspective that was very killer features from ArangoDB that was crucial for us, right? So first of all, as I just explained, the the data model of Spline is a graph, right? So we wanted to work with the graph as a graph. We wanted to store the graph in the graph database and query it as a graph, traverse it as a graph, etc. So naturally, we were looking for a graph database. There were a range of different graph databases at the time, but the problem is we tried a few, but the problem very quickly occurred that not everything can be efficiently modeled as a graph. Yes, we could model basically pretty much everything as a graph, but for Hello World it's okay. But when you store, let's say, hundreds of thousands and millions of jobs and events and execution plans and operations, etc., in the graph database and try to access everything as a graph, it becomes really slow, right? So we wanted to use a proper, more efficient storage for certain data, for certain queries, so that we balance between the functionality and between the performance, right? So we wanted basically a polyglot storage, right? And ArangoDB offered the multimodal paradigm that basically was just a really killer feature for us. So we didn't need to decide, okay, what type of data we will be store where, some in the SQL database, some in the document database, some in the graph database, etc. Right? We have everything in one place, and we have a one language that we can use to basically call any piece of information at any specific time in a way which is more efficient for that particular scenario, right? So every single piece of information can be queried by ID, let's say, as in Mongo, as in document database. But in other scenarios, it's more efficient to find it as a graph using some connections, right? So it's very flexible, very useful.
So my question here is that are you using, because this is essentially event store capture, right? You understand the event, you capture the event in the event store. And my question is, do you use RDF reflex to store, or you're using what type of graphs you're storing in? Because we also have an RDF adapter. So how you're storing those graph information?
No, we do not use RDF. We store graph information just as a graph, just as a collections of nodes and edges, right? But we have our data model, which is this one, right?
Because Tommy here, RDF provides the reasoning capability, and you were asking question about which particular node break it. Now with the reasoner like Hermit and other things, you can run reasoning capabilities, and you can ask a question which, if you're storing in RDF, use RDF reasoner, it can tell you exactly what is going wrong. So that was the reason I've asked this question. That so in order to find which particular node in the graph is broken, so you are executing the queries, right? So but the reasoning capability which RDF natively provide with like a Hermit reasoner and all those things, that particular capability, how do you handle that? So how do you reason it out that, okay, this is where the graph has broken, this is where the problem is. So you are capturing the event, you're building the graph, particular node failed. How do you detect that node failed?
When you say reason, what do you mean? Like using a language model?
No. RDF natively support reasoners.
RDF query,
Yeah, RDF, support reasoners. Sometimes you can run the query to reason it out. It can provide you.
Because you got the semantics in there, right?
Yeah. So I just want to understand, how did you crack this problem of finding which particular node broke, and person can figure it out, because it's a nice observability capability, right? I want to understand why my pipeline broke.
So if you've got like a third pipeline, and it's broken because of the second or the first? How would he go about detecting that using the software? Is there a...
So I don't really understand what do you mean by detecting it. Spline itself does not do any analysis of the business logic. It provides you the visibility to the lineage, but you as a user can explore the lineage, and if you spot some error, some problem, you can then use the same system, the spline, to understand what was impacted by that error, and if that error was not the error in your business logic, but for example, it's a data error that came in one of the inputs of your job, then you may use lineage to basically to try to understand what was the upstream and try to find the real culprit. Right?
Is there a pattern or a methodology of figuring out where the root cause of an issue is? Is that done through queries, AQL queries, or is it done through UI? Is there something you need to add?
I would say that's mostly done by the UI, right? But of course, it's important to reiterate in the beginning of this presentation, I said that one of the objectives of Spline was to basically create a platform that can be adapted for specific scenarios. So if in your organization there is a specific scenario and you want to implement a specific feature to look for some, I don't know, for some specific anomalies in the lineage, like maybe missing lineage or something like that, or maybe you know how to detect some errors in logic automatically, and you want to make it a feature of Spline, it could be done, right? So
it's not a data observability or data reliability. That's the key.
I think it gives you the information to build on top of that.
On top of that, you build a data
And-
reliability.
And I think like a lot of open source projects, it's designed to kind of have that base level, and then people will have built on top of that. I think at the moment it's mostly about capture and visualization, but Alex is going to talk a little bit about kind of where he sees it going, which will link to some of the stuff Tony was talking about.
thank you. Cool. So demo time. All right. So let me quickly show you the UI. Okay, so I'll start with this. Okay, so remember this slide, right? So we have a bunch of things, right? We have a Spline server, which is a standalone server exposing two REST APIs. We have a ArangoDB cluster, and we have a agent that for the purpose of this presentation, I will be using a Apache Spark agent. It comes along with Spline. It's pretty much a mature agent by itself, and I will be running some Apache Spark jobs, and we will see how the lineage is captured from the Apache Spark, right? And then we have a Spline UI, which is again a very loosely coupled service. But this is basically a single-page application. Nothing really fancy. Single page that is using consumer API, REST API, to capture the aggregated lineage information from the Spline server. And this is how it looks like. So all the components are Dockerized. So I'm running a Docker container locally. This is basically a status page for the Spline server. So we see that it's running. We see the information about APIs it exposes. the producer API and consumer API, and that's it. So nothing really interesting is going on here. And the UI looks like this. Okay, so this is the UI we currently have. One of the problem for the project since the day of the inception of the project was that every stakeholder was asking us to basically to capture the lineage from everything and just capture, but nobody was actually able to tell us what is the expectation, how to get value from that lineage, how the UI look like, what the user scenarios, etc., right? So the UI currently is some sort of like a demo shape, if you like. We of course made up some scenarios for ourselves how we think it could be used, but it's not, in my opinion, it's not exactly in a shape that can be used like in a production for some specific company. Although some companies are using Spline UI in this variant, how it is on their production, and it's fine from them. But what I'm trying to say is that I would not treat it as a like final product, right? But rather as a demonstration of how the lineage information can be presented and what can be built on top of that. Okay, so for example, this particular page shows you the execution events that were captured by Spline. So basically, every row is a information about one execution event of a particular script or Spark job in this case that has some name that produced data in the Parquet format in some file, in some destination, right? And this event happened at some particular moment in time. So, for example, I have this demo pipeline, right? So I have, let's say, standardization job for some sales CSV file. So imagine I have three data sets: sales, users, and products. Right? So I have standardization for every of these file, and then I have sales enhancement job that uses consumes information from standardized users Parquet file, from sales CSV, and produce some results, right? Some enriched sales Parquet file. So, and on this particular graph, we can see that it shows us the lineage for the data that has been produced by this sales enrichment job at that particular time, right? So it shows that that job consumed two files as an input, and one of the file we know that was produced by another job before that, right? That in turn consumed raw user CSV, etc., etc. So this is how the end-to-end lineage presentation looks like in Spline.
This is at table level, or
Sorry?
do you go down to attribute level as well for lineage?
This is a high-level representation that only consists of jobs and data sources or data sets, right? Nothing else, right? If you want to drill down, no problem. You can drill down. You can drill down, for example, into the sales enhancement job.
Yeah, just one question. So is it agnostic of the cloud provider that you're running your pipelines on?
Totally agnostic.
So for example, if I'm running my pipelines in GCP, and if I'm having a dead proc, which is getting invoked maybe from an Airflow, where I might have multiple Spark summits. Yeah. So how do you? I mean, is it real time? I mean, when I say, when the data proc runs through that Airflow DAG, right? For example, is it pulling the data real time from the cluster? Or is it at stage level? Once it moves from one Spark summit to another Spark summit, then only it knows. I mean, just wanted to understand how you fetch the data to show the lineage.
Do you want to know if it's capturing while the job's running,
Yeah.
or at the end of the job?
Yeah, basically, yeah.
So I realize.
So the current agent that you've got a Spark agent, right?
Yeah.
Does that capture data while Spark jobs run, or does it capture after the Spark?
No. That's real-time information.
It's real time.
Yeah.
And within the Spark job, right? So say, for example, once the CSV is loaded to your data frame, say, for example, and if it's doing a bunch of transformations on it,
Yeah.
is it capturing that level of, or it's just what goes in and then comes out, maybe?
No. That's in this particular case, when we are talking about Apache Spark, it captures everything.
All right. Yeah.
Spark allows us to basically to pull everything, the entire execution plan with all the possible technical details from it.
Yeah.
Spark is not Scala, that's the JVM language. The expose query plan,
Yeah.
you can run your own agents, it can go nuts actually. You can even get data from it.
Yeah. Fair enough.
So
Yeah.
I think it's something to do.
Yeah.
The agent that you built, the Spark one, so that I'm assuming it just works as is on EMR and Dataproc.
Yes,
Not
it is.
anything that's
Yeah.
Apache Spark related.
Yes, it is. As long as you are using Spark regarding the environment, the agent should be working.
Is the agent packaged with your Spark application?
The agent is a separate library. Spark is a Java application, so the Spark agent is a jar, just a jar, which you can download from Maven Central and just put into your either Spark distribution or submit it together with your job to the Spark cluster, and that's it.
If you're running an email job, you can say Java minus agent name of the file or name of the repository, that's it.
Yeah.
You just make sure that you're running your EMR job. In your case, for example, you have a file set on the EMR.
Yeah, just have that part of the profile. Yeah.
So the only thing I will show you how it's run. So the only thing you need to do specifically in order for the Spark agent to work is basically to instruct Spark to enable to hook up that event listener, which is Spline, right? Because in Spark there is a concept that is called SQL listeners, right? And this Spline agent is just one of the implementation of that listener. You just need to instruct Spark to call that listener on the event of execution, and that's it. Everything else happens automatically.
Just a few settings on the way you set up the.
It's just a
Spark.
configuration line. Yeah, nothing else.
So say that.
It's just a configuration line. One configuration line.
So I've got a big question, Alex. So
Yeah.
instead of Spark, if you've got a PL SQL stored procedure running on Oracle,
Sorry, say it again.
like instead of Spark, you've got a PL SQL stored procedure running in Oracle database, moving data from one source to target. Does the agent also understands that?
Sorry, don't understand.
So you're talking about anything outside of Spark, yeah? So other, like, let's say you're just running some SQL scripts.
Mhm.
I guess the question is, how would you capture non-Spark data?
We are talking about Spark, right? So SQL Spark.
No, in this case,
Stored procedure in Oracle.
If it's not Spark, then it's up to the agent how to capture this information. We do not provide the agent for Oracle, for example.
It's a possibility you can do that in Gold Wave if it's easier to set the events in the table. So that's how you can bring the events into the system. It's a more involved setup in that case. It's a more complicated setup, but it's possible to do that. Well, then, as you explained, but they beautifully that it's a user API. You just send the events. You don't care from where the events come in. So you can set it up yourself.
each vendor is going to have complications in how you get that metadata. So it's up to that vendor, right? To build these.
X or Y kind of files. So you can use these file systems with which you can enable things.
So we have a defined API for capture and lineage, right? Which is this one. Yeah, producer API specification. Right, this is the REST interface. You just need to write an agent that can capture the lineage from whatever system you want, if it's right. It's not a WebSocket. It's normal REST. Yeah. Right. So just create a JSON form, JSON in this format and execute post. You need to provide the execution plan and execution event, and you are done. Right. So this is in a nutshell all that agent does.
Can you show how you configure it with Spot?
Yeah. Let me show you it. Okay, so let's look at the UI. So for example, okay, let's focus on this particular example, right? So we have several raw files like user CSV, sales CSV, and there is also some product CSV. We have a standardization process for every of them. And then we have a sales enrichment job that uses some standardized, some of those standardized data sets, produce enriched data set, which then can be used to produce, let's say, final report. And the final report, let's run a Spark job to produce that report. So that would be, okay, let me, oops, that was wrong call. Got demo reporting. So for example, I have this normal Spark job written in Python. Nothing specific, no notion of spline, whatever. It's just a normal Spark job that reads from enriched sales Parquet file, users standardized Parquet file, and combine it with the product standardized Parquet file, and outputs the result into some sales report CSV, and have a bunch of dummy transformations inside. Right? So normally when I execute it as a Spark job, that would be, let's say, PySpark, like this. Demo reporting, right? So I have a Python script for PySpark. I just run the PySpark application and feed that Python codes to the PySpark. But that will work for sure. But I will not get any lineage from it because Spark is not instructed to do anything. Spark is unaware of Spline, right? We need somehow to instruct Spark to basically to kick off the Spline agent. So this is done by specifying a one line in the configuration. If we open this Spline Spark agent project on the GitHub, there is a documentation. And if we look at the codeless initialization technique, there is this example, example of the command line that needs to be executed. So basically, first of all, we need to add agent into the job as a library, right? Because Spark is a Java application written in Scala, it's important to provide the agent which is compatible with that version of Scala that is used in your version of Spark. Unfortunately, there are binary incompatibilities between, let's say, Scala 2.12 and Scala 2.13, and different versions of Spark using different versions of Scala. So we physically cannot provide one agent that is compatible with any Spark version. So that's why we need to figure out what Spark version we're using and what version of Scala is that Spark version is running on. So we need to execute not Python, PySpark, let's say version. Yeah.
So that means that source to target mapping will not be captured. So for example, the Spark data frame or Spark dot info schema, those capabilities will not be captured.
Excuse me, can you use the microphone maybe, because I barely hear you.
I'm saying is, since you are using Spark listeners, the data frame operations like schema operations, source to target mappings will not be captured because it's not a classical Java agent which is intercepting the data frames call. So I think sometimes it's very important in the Spark world to also capture source to target mapping so that you understand what is happening. So how do you do that in this case?
It is captured. It is captured because Spark. Okay, so if you know Spark, there are two main APIs that you can use to do transformations. One is the RDD API. Another one is data frame API, right? RDD API is more low level. Unfortunately, because of the low level nature of that API, it's difficult and physically almost impossible to capture the detailed lineage, the detailed execution plan, right? We have some support for RDD, but there are limitations, right? But fortunately, nowadays almost nobody using RDD directly. Everybody is using data frame, and the data frame is logical, is more high level of API. It has a logical execution plan, which is created first and then converted into the low-level RDD operations, right? And Spark, when this execution plan is ready, Spark is able to provide the entire detailed execution plan to us, to our listener. And it doesn't matter if you are using Python interface or Scala interface or Java interface or SQL dialect of Spark. It doesn't matter, right? Internally is the same thing. It's going through the catalyst. The execution plan is created. Spline agent captures that execution plan, parse it, analyze it, creates a lineage metadata, and send it to the server.
That high-level plan is probably enough. That's what the business is looking for a high-level lineage.
Exactly, it contains everything. Yeah, it contains everything except for the only thing it doesn't contain, it doesn't contain the physical execution plan, so we cannot know, let's say, how certain operations are breaking down into small operations for the sake of optimization and stuff like that, right? We have limited ability to capture some execution metrics, but that's a physical level. We don't really care about that physical level that much, right? So the logical level is what we are really interested in. Okay, so let me very quickly run the job. So we took a look at the PySpark that we're using. We see that we're using Scala 2.12 and Spark 2.5. So that's the version of the agent that we're going to use. Packages. Right. So the way it is done is since this library is available at the Maven Central, we simply provide the Maven coordinate for the Spark, for the Spline Spark agent, specifically for Spark 3.5 and Scala 2.12, right? The latest version of the agents 2.1. This way we basically provides that library to the PySpark, but we also need to configure Spark to execute that library. So there is another configuration line which is mandatory, is this one, Spark SQL query execution listeners, and we provide the name of the listener, Zacops, Spline, Harvester listener, Spark query execution listener. This is the part of Spark API, how to enable custom listeners, and that's it. And when the listener is enabled, the only thing the listener needs to know is where to send the captured metadata to. So we need to add one more configuration line that would tell the Spline agent where your Spline server is sitting. In this case, we're using HTTP lineage dispatcher producer URL, and we provide the URL that we can copy from here. Just URL for to the producer API. That's it. All right, and that's pretty much it. So we simply now execute our Python job. Sales reporting. Demo reporting Python. The job is executed again, but this time it pulls the Spline agents from the central, along with a lot of other libraries, etc. And in the end, what we have is this. Right? We see that there is a new line appeared on the execution event list, demo reporting. When we click on this, we will see the lineage of the data that was produced by our reporting job. So we produced some report, and when someone wants to take a look at what actually data was used to produce that report, here we are, right? We can see that, okay, this report was produced by that job used 3 other files as an input, and we can see the lineage for every of those files that were used as an input, etc., 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 etc. Up to 5 minutes.
5 minutes.
Yeah, sure. Right. So, and I guess I have enough time to show one interesting scenario. So, let's imagine that we are the team that is responsible for the demo sales enrichment job. Right. So let's take a look at this job specifically. Okay, you can see that this job uses standardized users Parquet file as an input and raw sales CSV file. And then imagine the situation that we received an email from the regulatory department that said that, yeah, by the way, starting from tomorrow, we must not use any raw data set for anything else except for standardization. So the company created a set of standardization jobs for every raw data set, and all the further analysis that is done on the data should consume only standardized data, never raw data. Right? But in our case, we can see that our enrichment process actually consumes the raw data. So imagine that I just returned from the vacation and I see that email was I don't know, 2 weeks ago, and but my job has been already deployed to production, so it might be executed already, and it might produce some output that is based on the wrong data set, and that output might already been used by other jobs that produce some reports, etc. So what should I do, right? One way, of course, is to write a mail to company all and start screaming around, but even that would not guarantee result, because another person responsible for some job downstream could be on vacation, etc. Right? So the best way, of course, would be to leverage the lineage information. If we know that all the jobs provides the metadata to Spline, so we can rely on the information that we can get from Spline to understand the impact of our job, and we can do it this way, right? So we call it impact overview or forward lineage, if you like. These graphs.
I'm just going to move that just in
okay.
case.
Yeah, this graph shows you basically the information about the downstream dependencies, right? We can see that, okay, this particular snapshot of data written into this file that was produced by that job was later used by this job to produce some other report. So what we can do, we can call that team up and ask them to rerun the job after we fix the error here. So how we can fix the error here? We can simply go to our job, our demo sales enhancement job, fix the error there, and rerun it, right? So let's simulate it. Okay, so now if we open the enriched sales Parquet file, we can see that there is a history of modification of that file, and we can see that there was 2 writes in that file. Right? Both writes happened from the same job, the same application or script or whatever, right? But at a different time. So if we take a look at the first event, we can see that the write was using the raw sales data, while the second write, no, this one, the second write consumed correct standardized sales data, right? But now we have fixed our job, but what has happened to the downstream report? If we take a look at the downstream report, we can see that there is only one write to that report. And even though this is an important feature of Spline because of the ability to capture the time aspect of all the events that happen, we can provide the true lineage, historical lineage, how it happened in time, right? So even though our enrichment job has already fixed, and currently, if you take a look at the job, it indeed reads the data from a correct place, everything, but because the error existed, it's some period of time before that, and it was consumed. That wrong data was consumed by some jobs downstream, right? We can verify that some of those jobs downstream, that every single report they produce, that it's based on an older wrong version of upstream data or already fixed one, right? So we, for example, here, if we take a look at the modification history of our report, we can see that, hey, this particular report actually based eventually on a wrong data, because it was run at the time when this job was actually in a wrong condition, and it consumed data that had some error in it, right? So, but now we know that we already fix that upstream job. So what we need to do is simply rerun our reporting job, right? If we rerun our reporting job, that we will basically get another version of our report. Okay, we see two writes now. The first write, the first version was based on the wrong data, while the new write was based on a correct version of the sales, right? So now we know that the most recent version of the sales report CSV actually based on the correct data upstream, and this is the reliable version that we can use it, and we can prove to regulators and to whoever we want, right? And the same way you can do basically the troubleshooting, etc. If I have 30 more seconds, I would like to show you how the attribute level lineage looks like. Let me find an interesting example. For example, we have a job here that incorporates some joins, some unions, and some other crazy operations, some filtering, some aggregation, even window there was somewhere, right? There's a sorting. So we can, for example, take a look at the very bottom right operation here. It's not really seen what's written there, but it says inserts into Hadoop file system relation, right? So this is the right operation. And on the left-hand side, we can see the input schema and output schema. We're interested in the output schema of this file. This is the schema of the output of this job, right? And we see that, okay, there is a, let's say, average score H2 attribute. What is it? I have no idea what is it. I can click on it, and the graph will show us the path in the execution plan, what other operations and what other attributes contributed to our attribute. So we can even see the dependency graph like this. So we can see that the average score H2 attribute depends on fancy score somewhere upstream, right? And from the perspective of the execution plan of this job, this branch goes through those filter operation, aggregate operation, etc., we can examine the whole path, and we can see how that attribute actually calculated. For example, here we can see the aggregate information that output average score H2 as a aggregate expression average fancy score, right? So we can represent it as a abstract syntax tree, etc. So this is a computational level of lineage for troubleshooting, for debugging, for whatever. Right. So this is pretty much it for the demo.
Right, okay, thank you.